Thanks, me
There
too.
was one, excellent. All right, first of all, prior to that, Zephyr gave a talk on various Perl6 bugs. I hope I don't run into any of them during the talk, as I wasn't here for that. And I will state up front that what I'm trying to show here is more of a minimalist approach to writing Perl6. So hopefully I'm not going to try, my intent is not to dazzle with hyperoperators and junctions and all of that. Hopefully there's a few new syntax constructs and a few changes to the regex that you know about. So relatively low impact approach. But we will, at the end, get into an interpreter and assembler, all done using a single Perl framework. All right, we'll start off, obviously, hopefully most of you have seen this already, but this is where you go to find Perl6. Perl6.org, obviously, is a starting place. Recruiter Brew is how I developed with this. It's basically the same as Perl Brew for Perl6. So you say recruiter build, and then the VM of your choice. In this case, I'm using more for demonstration purposes. And of course, for help resources, you can always go to Perl6.org. I'm sorry, the Perl6 IRC channel on freego.net. And they're all, I'm there on occasion, when working anyway, and I can help you with questions on parameters and zero expressions, and hopefully work through some of the problems that you might have. As there was recently a fairly major shift in how regular expressions how lists actually work, and I managed to get caught out by that. So while I do have a fairly large Perl6 parser and interpreter out there called Perl6.ember, right now it's still about 80% done converting from the great list refactor. So it's not quite working yet. But what that does is it lets me translate grammars in Antler from, I think I didn't have a slide of that. Okay. It lets you translate grammars that the Antler tool can use. So you can take a JavaScript Antler grammar or a Go Antler grammar and turn that into Perl6. It's not quite done, but it's almost there, and I was hoping to have it ready by the talk by Perl workshop. It's not quite there yet. I will let people know when it is live and ready. All right, for those of you that don't know anything yet about Perl6, let me clue you in about the first major change that you'll see in regular expressions. You'll note that we used to have the equal tilde operator, which changed to the tilde operator. Yes, this is basically the smart match from Perl, what was it, 5.16 through 5.20 or thereabouts. But it's now been repurposed. And there is actually a rationale behind the change, which I'll cover. You sound worried. Okay, sorry. The first rationale, if you look at the statements here, one of the things that I found that catches people out time and again on the various, on say Perl6 or on Facebook or even LinkedIn, that catches people out is why all the other operators behave like yellow, no, above, plus equals, minus equals, percent equals, etc. And the Perl match operator is the wrong way around. First thing, thankfully there's not here to tell me differently, but is there, the original Perl 5 way was there to call that out because is the wrong way around, and because it does things differently than the plus equals, the minus equals, etc., etc. So that it calls that out to say something is different here. And that is because we have a right side that doesn't necessarily do, a left side of the operator that doesn't necessarily do what you expect. In the case of, for instance, plus equals 2, $x mutates. In the case of $x not equal $x mutates. In the case of pipe equals, $x mutates. In the case of $x still equals /foo, $x does not mutate. So that was a major design. That was one of the major ways to call that out. Instead, in Perl6, we use the till prefix to the characters. And so now what we have, don't worry, we're not going to use any of these other operators. We're only focusing on the till operator. But the rationale now behind Perl6 is that the first character in these operators tells you the type of operators you're working with. For instance, the caret operator tells you that you're working with Boolean constructs, which is why we have true on the right-hand side. The plus operator by match tells you that you're working with a number operator. You're working with a number. And likewise, the /foo tells you that you're working with either a string or a real expression on the right-hand side. So the operators have now been separated a little bit and made a little more rational, so that you can go in and have a equals now. That follows the same fashion for equals or even plus or type operator. But that's a lot of talk about that's a lot of talk about one little operator. So let's delve into the core of the talk. The first thing I want to point out, aside from my own module, is that util has his own Perl5 to Perl6 conversion if you want to, say, take your test suites and convert those over to Perl6. I've done that myself with my module, which unfortunately I haven't renamed yet, from Modify, or on CPAN it's known as Perl to Perl6. I've taken Dancer 2 through the Dancer 2 conversion, the Dancer 2 test suites through the converter. And after conversion, roughly 80% of the Dancer tests pass. This is not to say that's for the Dancer 2 modules. It's just for the Dancer 2 tests. But it handles conversions. It handles the equal till to till, which gets a little bit confused because there's now obviously the dot till, the dot operator has changed, the dot operator has now changed to till, the till operator has now been replaced with double till, the equals till has now been replaced with till. So it's something that you probably don't want to do by hand. And if you look on GitHub, you'll see these two modules out there to help, and hopefully there will be more coming up. So let's start with attacking a fairly common expression. This is in ISO, was it 9601, I think, or 8601. I'm sure someone will correct me. Expression. What we're going to do is parse this now in Perl6 and a little bit in Perl5. The way we used to do this is above that \d plus dash \d plus, etc. The first thing that you'll notice here is that the dashes are now / in Perl. This is a new consistency rule and makes things much simpler. If you have, say, a relative in Perl5, one of my personal problems with that is trying to match a bracket, match a closed bracket, match an open bracket, match a brace, because they'll have backslashes, maybe, sometimes, unless they're preceded by a dollar sign, in which case you have more backslashes to match that. Luckily, the new Perl6 rule is much more consistent. If it is not an alphanumeric character, backslash, or quote, I'll get into the code help here very soon. So that's one of the major changes that is made in Perl6. So the next bit here is that Perl6 expressions effectively run with backslash with a /x modifier. So you can introduce white space without disrupting your current matches. So you can have white space in, you can have new lines, you can have whatever you like, even comments in there. I believe that Common book recommends /NSX for all regex modifiers. That's what you effectively get now with Perl6. For better or for worse. Capturing, luckily, has not changed. You can use actually square brackets to represent a non-capturing group, but we'll talk right now just about captures. Here we're going to capture just the date, the time section, and the time zone. And again, hopefully everything here looks relatively familiar. Again, the dashes and colons have to be escaped. But that's, again, now a consistent rule. If you've ever worried about where to put backslashes in your expression, don't be worried. Again, the rule is now, if it is a non-alphanumeric character, you need backslashing. I'm not sure if that applies to say, Indian numerals, but that's a different story. Now, one thing that I found that is a real boon to at least my core development is this. You would think that you ran this expression through Perl6. Now that everything is either an object or everything is now an object, you would think that you would get a hash reference if you try to look at the output of a mesh. Like so. You think so. But luckily, we now get a nice clean, we now get an actual data instead of wasting time trying to go back to the previous statement and add in data number, add in dump parent, add in dump parent, this, like I'm sure all done, or my personal favorite, use YAML much shorter, and use YAML and then use YAML, say, dump this thing. We get back an actual decent indented tree. The funny square brackets around there are the Japanese quotation marks, deliberately designed to be deliberately designed to be out-of-band characters, so that you don't miss. So when you copy, you'll get Unicode immediately. You just want to try to copy that somewhere. Trying to verify. Okay. And we have all your rate indexes automatically marked out for you. Whereas before you used to say you used to have to with $4, $0, $1, $1, $2, $3. Just take a look at the way this slide. You now actually have a straightforward and simple array to work with on matching objects, which does look a little bit more awkward when you look at in raw total, because you end up this way. You actually get a lot more information, but I've in this case cut out about 15 lines worth of statements. But again, if you need to know the detail, if you need to drill down that far, then you can. You get, for instance, the original string that you're matching, the match index, the start match, the end match. So if you're looking for, say, the time zone, you find a list over here with the time zone reference, and it starts at character 11 and goes to character 19. So you have a lot more detail and more depth as to what actually goes into this. Now, it used to be that you'd say, you used to use $1, $2, $3. Well, that's kind of a reward, at least in my opinion, in Perl 5. And Perl6, luckily, $0 has now moved over to $star program name. So $0 is now free to do what it should have done all along, and be the zeros match in that string. And again, here, date is 2015-11-11. The time is 22:21:37, and the time zone is Zulu. So now it's a slight change, and again, luckily translators such as Blue Tiger and Chronomography do this for you, if you want to go that way. There's also now a match object. So you have, along with the old $0, along with the old $1, $2, $3, you have now an actual match object, which has a sensible name, at least a sensible schematic. You are matching strings. Your string matching operator is //. So what's a more sensible name for the match object than $/? Straightforward, intuitive, and keep intuitive and keeps things in order. I'm not quite sure. Someone has to explain this to me, unfortunately, why $/ is in fact indexed with an array here. But $/ now $/0 is the first index of the match object, which matches our date, 2015-11. The second object is 21 December. So that's another way to match. You have the old $, you have the relatively familiar $0, $1, $2 variables available, or you can go a little bit more new style and use the $/. Or one feature that I haven't seen a lot used in a while so far is the capturing from Perl 5. Probably because it's just a little bit awkward to use. Luckily, Perl6 clears it up for us quite a bit. You can now create a regex, which matches your content, $/d-/d+/d+, and captures the date portion. And instead of, parent, question mark, open angle bracket, something akin to that, to capture text. Now all you do is replace the string that you wanted to match. Let's see, all the way back here, the parent d-/d/d. You replace that with an actual label, with an actual relatively same, easy to remember ASCII string called date. And inside there you use the HTML-ish angle brackets to insert your date expression. And down here, at the bottom, to view that, much like you have the $/ object, the $/match object, it also is a hash, so you can view the hash contents. This is another slight new piece of Perl6 syntax. You probably know this actually as a hash key, but the pointing brackets on both sides are now how you delimit a bear word. In old Perl5 code, if you said $x brace foo close brace, that now has changed slightly in Perl6. It is now %x because of the new sigils. Open point bracket, foo, close point bracket. And basically anything inside, I believe the rule, anything is that anything inside the open bracket, the close bracket, is now officially a variable. And I'm sure that people will. I'm sure that. So if we want to go all the way with our expression and break it down even further, we have a date and time and time zone. And by the way, again, notice I failed to mention this beforehand, but notice as well that the expression that we have here, we're actually yes, the quote 2015 has no white space. Yet our math expression has as much white space as we want. You can insert white space wherever you like to keep things clean and separate out different business expressions, or put them on new lines, put them wherever you like. Keep things separate and keeps things clear. And I'm right now having a hard time flipping back and forth between Perl5 and Perl6 for expressions in my mind. So at work I tend to write Perl6 expressions and then be surprised why they don't run. Okay, I might actually have time to do this for this. Cool. Okay, so before we get into the next portion, which is actually using expressions to do something that regular expressions cannot do, let's go on a quick recap. We mentioned before at the start that the new operator is tilt. Or we mentioned as well that white space is now completely optional and effectively acts as the /x modifier. And if you have questions, by all means, go ahead and yell them out. I should mention that beforehand. Right. Moving onwards, the next bit to remember is that anything that is not alphanumeric needs to be escaped. Again, I find that the rule to be much more consistent, having gotten caught a long time doing parsing algorithms and trying to match on a dollar sign or an S sign inside brackets. I always forget how that. I always take about 15, 20 minutes trying to remember how the actual matching expression works, and then say, I put into a QX, QR, and match it as a dollar sign expression. Last thing, I'm not quite done yet. $0 is now the start of the matching. So $0, $1, $2, those now are match variables. Instead of this weird offset $1. More straightforward. Again, at least to my way of thinking, more straightforward. And we now have a new type called regex, as opposed to the old Perl5 way, where if you've ever, say, written a free walker, you know that there is a problem trying to distinguish between a West class that you created called regex and the actual internal regex inside in a regular Perl QR expression. If you run into that problem with your data utilities, with your YAML utility, with anything that does engineered free walking. So now that we have a first class data type called regex, or I think that's actually a named block. So it's not quite a regex in the sense, I'm sorry, not quite a block in the sense, in that sense we have that. So, little break here before we move into the next section. This sort of builds a lot of the content that we looked at before, especially it will focus on the my regex portion of this. What we're going to do is take a regex and do something that regexes can't do, at least not without introducing more code. One of the problems that you in computer science and teaching that people canonically talk about is how brace expressions cannot handle matching braces, or alternative another problem in computer science usually is that they can't count pairs of A, B, A, B, A, B in a brace expression. Something that brace expressions cannot do. But luckily for us, what Perl6 uses are not braille expressions, but parser expressions. And we'll start out here again in baby steps. And start with this phrase here. We have an integer that we want to match in string. So the opposite there is to create a regex, call that an integer regex. Now in this case, we're not going to worry about sign, but you could add that later on. We're not going to worry about floating point types or sign with notation, because you can add those in later on. If you're never to start what we were talking about, the angle bracket integer is now how we match is now a better and hopefully clear way to match expressions. So say, let's take a JavaScript-ish language. So we have 32 here, a integer, and we want to add a variable, a. Well, one thing you do there is you create a type for your integer. For the moment, we're going to throw away the a because it's actually a little more complex for where I'm headed. If you want to match this way, we can just deal with simple base integers. So we're going to extend our regular expression, vehicle common expression, to a sum, to match the sum of any two integers. Now, the first thing you'll see is when you have the match object here is that we actually have something called a free formula. And that's what the indentation on this side indicates how deeply we're nested into our real expressions. And those of you that know a little bit about parsing and compiling might start to recognize this just a little bit. A tree being formed from a set of expressions maybe just a touch familiar. For instance, integers here are just strings text with no white space, and more importantly, for our purposes, once the regular expression parser has gone through the 3-2 to capture that regular expression, it no longer needs to backtrack. So what we're going to say there is that after you parse 3, 2, and however many other digits we have after that, we'll just call that a single token. As if you were, say, parsing, as if you were matching contents of a file. If you were, say, looking at a portion of an Apache log file, trying to match dates. If you're looking at a portion of, say, JSON, trying to match a string. If you're looking at, say, portion of a JavaScript program that was parsing. So what we have here is a tree starting to form inside our expressions. So if we were to say lock that tree later on, and we knew how to go in and look at, say, the expression inside that, and look at the integer inside that, and if we were to do some sort of manipulation with those two. So, say we want, I made one other change there. Sorry, I should point out this as well. We have the token type here and the rule type. The only real difference, I think, and I will have to correct myself later on, I'm not sure, is that the rule is a little bit more flexible with how it interprets white space. That's the only real difference between the two types. So in this case, I didn't include white space in the example for reasons of clarity. But this way you can include white space between the 32 and the plus, and or say a new line, white space, new line, what have you. And that's really the only difference. But the important thing to focus on here is that we're looking instead of at a random expression that you would, random expression that you would match with $0, $1, $2. You now have labels that you can refer to inside that match. So for instance, if you want to, you could actually go into the $/ object, as we mentioned before, and open $/ angle bracket sum, I'm sorry, I have an error on my slide. $/ angle bracket sum, angle bracket 0. Raise 0, because there's no way right now to differentiate between these two integers down here. The expression and integer down here. Because luckily for us, they're inside an array. So you can match it with $/ open bracket sum bracket 0 to get 32. And for $/ open bracket sum bracket 1 to match 16. So you delve a little more deeply into your data structure that way. And it starts not looking so much like every expression as something that you would see as, say, a parser or compiler that was going through and interpreting your data. A little more complex, a little bit more complex, not that much. Again, you have the token that you can name, and you can use it anywhere in your realm make it like you have a sum that you have a sum object that you can use elsewhere in your program or in other programs, or say create a library. If you have a lot of these sort of operations like integer plus integer, integer times integer, you can name that as say sum or product, and put them into a library. We might call it an expression library. Other people might call it a parsing library. So this is where we get just a little bit deeper into how what we used to have as just a set of regular expressions is now more of a parser or compiler. So that what you can look at, so that what you start out with here, and what you end up with is basically something that you take and parse yourself. You take this and parse that and interpret that. So you have what was an expression here is now a bit of compilable code. One of the canonical things that you see a lot of times online is people that want to use your Perl expression engine to say evaluate a string. It's not a common thing. If you have a log, you have a configuration file that you want to that someone has put an expression in that they want to match and interpret, well, that's a little bit awkward in Perl 5 because you have, say, / integer, then capture the plus sign, and capture the multiplication sign, and then later on in your code figure out, okay, $0, $1 is an integer, $2 is a multiplication sign, so you have to say if the sign is multiplication, then return $1 plus $3. And move on from there. So right now, what we get is parsing the yeah. So no worry. Again, we have a little bit more of a tree going on here than you see. 42 plus 7 was our original expression, and we've now broken that down into, what's here at the sum. I deliberately hid a few things back on this slide because Perl6 gives you a lot of information, which is, again, great for trying to debug these problems. The more information that you have, the better. And right now, if you take a look at, I've been doing some work with parsing, of all things, parsing a parser algorithm. What you get out of the done is wonderful compared to what you will used to get if you, say, try to do this with an older model, say Parsing MCP or Parsing, and trying to debug those in Perl5 used to be a nightmare. Now it's all built into the language for you, and you have automatic tools that spit out relatively easy to read data trees that you can view. So this is what it actually looks like on the interior. And we have the 0, we have the element 0 here is our integer, first integer, and element 1 is 7. Which is okay if you're just doing random, which is okay if you're just trying to match that. But if you want to, say, write an interpreter that will return the value 39 from that, then it's kind of helpful to know what the right-hand side of the expression is, in our case 32, and, the right-hand side expression, which in our case is 7, and the left-hand side, which is 32. It's helpful to know that sort of thing if you are trying to write an interpreter. So when you end up, this way you can tell apart the left-hand side and the right-hand side of that. So we create an alias now for our capture statement. So now we can go in and be able to match $/bracket LHS plus $/bracket RHS. And know which one is the left and which one is the right without having a label. So now, we'll have to hurry up a little bit. The last bit, what we're going to do is, as I've been hinting throughout, is we're going to create a very, very small interpreter for this expression, with the goal that we can take 32 plus 7 and get the result 39. Effectively creating an interpreter form language inside Perl, inside a grammar, which I know sounds much like Inception, and I wish I had the Inception noise at this point, but I couldn't find out mine, at least not at 3,000 feet. Didn't quite work out very well. So what we do is we add to our grammar, we add an action that tells the compiler whenever you process a sum, you do this. When you process a sum that has a left-hand side and a right-hand side, inside that you do something. And what that looks like is this. This is your action here, your interpreter. So for, say, a sum, you can return the sum of your left-hand side and right-hand side. The make statement there returns an abstract syntax, returns in a syntax tree. In our case, what we're doing is not creating a tree, but the actual sum of two expressions. This shortcutting a lot of the current Perl6, shortcutting a lot of the old expressions. So now, effectively, you can take this grammar and modify that later on to do, at home, to do addition, subtraction, multiplication, division, all the major operations. Add in, say, variables to that mix, and create your own little language inside Perl6, inside the grammar. The last thing I'll show you before I run out of time here is this has a lot more Perl6 code, and this is one simple way to write a very, very, very small assembler to return your code. Of course, you don't really want to assemble such a simple instruction that just simplifies in your front end to 3.9. But if you wanted to replace, say, the integers with variables, then you have a legitimate use case for creating an instruction. So again, I will casually mention, I should say, that there's already the start of a project like this to do this sort of thing that we do for assemblers in Perl6. This is again my own project, and this is what I'm just now finishing up after programming. But what is there right now is all the DrForr grammars for popular languages such as Go, such as JavaScript, such as C, which is kind of important one because it'd be really nice to be able to generate native call expressions from Perl. So if you want to give it a try, then by all means go out to GitHub, and once I got things, fixing in for the latest change to Perl. What you'll be able to do is take this tool, create a grammar for Go, and be able to parse Go inside Perl6 and say return Perl6 code. And what this does actually is takes the ANTLER code and parses that into Perl6, which is terribly amusing, at least I think, because the current ANTLER code to generate backends is roughly, I think I measured 25,000, possibly in excess of 75,000 lines of Java code to do what we do in Perl6 with, I think, 1,200 lines of Perl6, and it's mostly grammar. So this shortcuts all of what ANTLER does, replaces that with this, replaces that with a generator for Perl6. Thus taking the entire front. And once we are now out of time. I don't know if we have time for questions. I don't think so. Okay. All right, one. Okay. Anyone? Okay.
Is it possible to do recursive grammars? So you go start at sum is left hand side plus sum and have a termination condition as well?
Yes, indeed. Yes, indeed. And in fact, the ANTLER grammars used in Perl6 ANTLER relies on that fact. Grammars are recursive, and if you know anything about grammars, then they are fully left recursive. Okay. Thank you very much.